Welcome to another session of Ebenezer Gate coaching classes. This is a problem that appeared in Gate 2023 for 2 marks. It's a multiple choice question. In the circuit shown below, D1 and D2 are silicon diodes and cut-in voltage is 0.7 volts. V in and V out are input and output voltages in volts. The transfer characteristic is dash. There are 4 options that are given. We'll have to find out what is the transfer characteristics. The transfer characteristic is a graph that plots V out versus V in. Now let us see what happens to the diodes when V in changes. Now we know that they are diodes with cut-in voltage 0.7. So if the voltage across the diode is more than 0.7, then the diode conducts and there is a drop of 0.7 volt in across the diode. So let's say, so D1 will conduct if the voltage across D1 is greater than 0.7. Let's call the voltage across D1 as V1. V1 should be greater than 0.7. Or V in minus 1, because the voltage, there's a battery here with voltage 1 volt. There's a battery here with voltage 1 volt. So V in minus 1 should be greater than 0.7 for the diode D1 to conduct. Now for the diode D2 to conduct, D2 to conduct. Now D2, the positive is near, the positive 1 volt is connected to the P junction of D2. So we'll have to say 1 minus V in should be greater than 0.7. So we have equation 1 here, equation 2 here. These two equations determine the output. Now equation 1 means V in should be greater than 1.7 volt, and the equation 2 is V in should be less than 1 minus 0.7, that is 0.3. So if V in is greater than 1.7, diode D1 conducts. If V in is less than 0.3 volt, diode D2 conducts. If it is neither greater than 1.7 and less than 0.3, or if it is greater than 0.3 and less than 1.7, then both will not conduct and V0 will remain. So it will be open, both will be open, and there won't be any relation between V in and V out. V out will remain at the battery voltage 1 volt. So if you write the equation, if V out is actually V in minus 0.7 when V in is greater than 1.7. When V in is greater than 1.7, D1 will conduct and there will be a drop of 0.7 volt across D1. So the output voltage will be V in minus the drop 0.7. And from when V in is less than 1.7 but greater than 0.3 volt, then both D1 and D2 will not conduct and output V out will be fixed at 1 volt, which is a battery voltage. Now if V in is less than 0.3, then there will be a drop of 0.7 volt across D2. So actually when we see the output will be 0.7 volt will be added to the input, because the direction of D2 is in such a way that the V out will be actually V in plus 0.7. So at when V in equal to 1.7, it'll start from 1 volt and it'll rise from there. And so at 1.7 it will start and rise from there. So here also, and 1.7 it is 1. These two cases, in A and C, it is happening like that. Whereas when V in is less than till 0.3 only, it will remain at 1. After 0.3, as it goes below 0.3, then the equation is V in, it is no more at 1 volt. It will come down from 1, it will be V in plus 0.7. So at 0.3, from 0.3, it will be related to V. So this is the only equation. A is only showing that it is V in plus 0.7. This is the graph of V in plus 0.7. This is the graph of V in minus 0.7, and this is 1. So the option A is correct. Thank you. God bless you.